previous video, I talked about energy changes in reaction, and today we are going to be picking up from there. We are going to be talking about rate of reaction. Now, the rate of a reaction is basically the time taken for that reaction, or rather, the rate at which it's inverse proportional to the time taken, and it involves the rate at which that the reactants are used up. So basically, when you talk about the rate at which somebody eats, is how fast that person eats. So, and basically, I can say apply it to chemistry and say that the rate of reaction is simply how fast a chemical reaction will go. Now, there are different factors that will determine the rate of reaction, and these factors involve temperature, concentration, the presence of light, the presence of catalyst, and the increase or decrease in surface area. So join me as we deal with each of these factors, and then I'll give illustrations. So basically, temperature. Now, the explanation for temperature is that whenever you have a reaction, for example, you have sodium hydroxide and hydrochloric acid reacting to form NaCl and H2. In some cases, whenever you increase the temperature, this reaction will go faster. So, and some of these reactants involve whenever you have solids, whenever you have liquids. So whenever you increase the temperature, you are increasing the kinetic energy of these substances. So then you are making it easier for them to reach their activation energy. So, and then this temperature has a very important role, because whenever this particle has greater energy, so they will be able to go hard enough. It's just like when you are launching a rocket. In rocket science, whenever you want to launch a rocket, there's a minimum speed for that rocket to achieve before it can break through the atmosphere of the earth. Now, it's just like for chemical reactions. So whenever you have the speed, which is whenever you have the energy, in this case, if the energy is just a little bit less than the required energy for that reaction, and that required energy is known as activation energy. So whenever this energy is just a little bit lower than that, the reaction will not occur. But the effect of temperature is that the temperature makes it easier for these particles of reactant, because in the previous video I talked about particulate nature of matter, right? Now, this matter, they are made up of particles, right? So, and these particles, each of them individually, they need to have energy. So only the particles that have enough energy to escape from the energy required for the chemical reactions, it's only those particles that will be able to perform the reaction. So for example, whenever you have we have chlorine water, or a chlorine compound, a chlorine containing compound, and whenever it's exposed to sun, and for example, even the combination of hydrogen and chlorine to form hydrogen chloride, it is very explosive in the sun. So, and that is an effect of light on the rate of reaction. But apart from that, many other reactions also involve temperature, combining of elements. Whenever you increase the temperature, you can see that the reaction will occur faster. But whenever you decrease the temperature, the reaction will occur slower. So what that means is that those particles, they need more energy in order to be able to escape, in order to be able to attain the requirements for that reaction. That is temperature. And then we have concentration. So what concentration really means is that those concentrations is that the amount, the number of particles in a given volume of the substance. So, and what the effect of increasing the concentration of the substance is that in essence, you are basically increasing the frequency of collisions. For example, in this sodium hydroxide and hydrochloric acid combining together, when you increase the concentration of the acid and base, the reaction will occur very, very fast. But when they are dilute, they pose little risk. That's why your teacher often asks you to stay away from corrosive and concentrated acids, because those acids, they are able to dehydrate the skin. Whenever it touches the skin, they perform a reaction on the skin, and that's corrosive nature is very strong whenever the concentration of the acid is strong. So, and then in general, rate of reactions is increased whenever you increase the concentration of the reaction. So, and because the frequency of collisions is greater. Next, we have effects of light. So, and then that's what I was talking about when I talked about the reaction between hydrogen and chlorine. Whenever they combine together in the presence of sunlight. So, and this sunlight emits energy, and this energy is in units called photons. Now, these photons, they are packets of energy, and these packets of energy, whenever you have this energy striking the chemical particles of hydrogen and chlorine, it increases the energy, and it makes it easier for them to achieve the activation energy. And the activation energy is basically the amount of energy required for the reaction. So in this, for example, in this one, when you have something like this, the activation energy is the peak. When you have the reaction, there's a peak they must achieve. It's just as when you throw something in the air, there's a highest point. Now that highest point is the activation energy. So if it doesn't react, if this activation energy is not achieved, then the reaction will not occur. So that is also an example of how light can help the particles to increase their energy and then achieve the activation energy, and as a result of that the reaction will be faster. Then we also have effects of surface area. The effect of surface area is that whenever you have particles, most especially particles in their solid state, and these particles they are reacting together, whenever the surface area is greater, that means each of these the particles, more of them will be able to react in a particular time. Just like whenever you have different phones and you want to maybe you want to make calls with those phones. Now you can people can receive different calls, or maybe we have a calling service, a service of people that give you phone to make calls. Imagine if I start a business and I started to 10 telephones and another person starts the business with 20 telephones. Now at a given period of time I can only take 10 customers, but that other person will be able to take will be able to take 20 customers. Why? Because in a given period of time there are more people coming. So and what that means is that in chemistry, if we abstract it to chemistry, what that means is that whenever you increase the surface area, you are increasing the amount of particles that are in contact with the other reactor. So and when they are in contact at a given period of time, more of them will be able to react. So that is why surface area increases the rate of reaction. And for example, if you have marble chips and pulverized marble, so that is marble that is grounded, that is CaCO3, simply means carbon trioxide carbonate. So carbon yes, calcium trioxide carbonate. So that's calcium trioxide carbonate. Whenever it is crushed, a lot of more particles will be able to react with the reactant. But if it is in the form of a lump, that means it's only the outward particles that will be able to react. So and that is why surface area affects rate of reaction. Then lastly we'll talk about catalysts. So and then catalysts, the effects of a catalyst is simply to reduce the activation energy required for a reaction to occur. So and then if we have taking this one, whenever we have a catalyst can take the activation energy from the top to a lower level. So and then instead of the reaction to go this way, you can see that reaction will begin to go this way. So and this effect of catalyst, this effect of reducing the activation energy will also make it faster for the particles to have to pass through the reaction process and carry out the reaction. So they are easily converted to the product at the faster rate. So an example of that is whenever you are preparing oxygen and you make use of something like magnesium oxide, MnO2 catalyst. Whenever you are preparing oxygen from the breaking down of potassium trioxychlorate, or whenever you are preparing from the breaking down of hydrogen peroxide. So whenever you add the catalyst of magnesium oxide, that makes the reaction faster and makes it easier. So in summary, we'll talk about 5 different factors that affect rate of reaction, which are effect of temperature, effect of concentration, effect of light, effect of surface area, and effect of catalyst. So thank you for watching.